Alright, let's look at the homework 6, problem number 6. Alright, so we want to find a particular solution y sub p of y triple prime plus y prime is equal to 2 minus sine of x. Alright, so let's find the complementary solution first. Alright, so characteristic equation would be r cubed plus r equals 0, right? So we can factor out r, and we have r squared plus 1. That's equal to 0. Right, so that will give us r equals 0, and also plus or minus I. Right? So the complementary solution is going to be, I'm going to just call it y sub c, is going to be, right, so 0, so there's going to be a constant, so I'm going to call it the c1, right, then plus or minus I, so it's going to be a sine of x and a cosine of x, so plus say c2 cosine of x plus c3 sine of x. Alright, so that's the complementary solution. Alright, then we pay attention to the right hand side. So right hand side here, and we have two constant term. So we, our first guess would be the y sub p would have a constant term, and the sine and the derivative was cosine, so we think of all possible derivatives. So you have a constant, the sine, and also cosine. Right, so initial guess would be y sub p would be, so there's going to be a constant, a, right, then sine and cosine. So I'm going to probably call it b cosine of x plus c sine of x. Right, but the problem is you can see that the complementary solution already have a constant, so we have to avoid the overlap, so we multiply the power of x. So in this case we can just multiply by x, so that the ax, to avoid the overlap with the constant term. And also sine and cosine are part of the complementary solution. So to avoid the overlap, so we're going to multiply by x again. Right? So this would be the form of the particular solution. Right? So what we do next is we have to find the a, b, and the c value. So we take the first derivative and third derivative and plug them in. Right? So first derivative, it's a little tedious. So take the first derivative. Ax gives you a. Alright, here we have to use a product rule. So derivative of x is 1, and times b cosine of x plus c sine of x plus x times, right, and we have to take the derivative. Derivative of b cosine is negative b sine of x, and plus c cosine of x. Right, so that's the first derivative, and let's take the second derivative. Right, derivative a is 0. Derivative b cosine is negative b sine of x, and then derivative c sine of x is a c cosine of x plus, right, derivative of x is 1, so you're going to get another negative b sine of x plus c cosine of x plus x times, right, derivative of that is negative b cosine of x minus c sine of x. right? And we can clean up a little bit. Let's see, we can combine these two terms, negative b sine of x and the negative b sine of x together. So we can get the negative 2b sine of x. And then we can combine c cosine of x. And there's another c cosine of x. So that will give us 2c cosine of x. Then we have x times negative b cosine of x and minus c sine of x. Alright, then we need another derivative. So y sub p triple prime. Alright, so derivative of that is negative 2b cosine of x, and it's going to be negative 2c sine of x, plus derivative of that would be derivative of x is 1, so you have negative b cosine of x minus c sine of x, plus x times, derivative of that would be b sine of x minus c cosine of x. Alright, then we can clean up a little bit, and you can see that we can combine negative 2b cosine of x and the negative b cosine of x. So that will give us negative 3b cosine of x. And then we can combine negative 2c sine of x, and you have a negative c sine of x. So that will give us negative 3c sine of x. And then we have the rest of the terms. So you have x times b sine of x minus c cosine of x. Alright, so let's plug those guys into the differential equation. So here we have y, the triple prime of y, so we have that. So we have negative 3b cosine of x. Oh, actually, maybe I should write this. All right. So I'm just doing, I'm going to do yp triple prime plus y sub p prime. All right. So we have negative 3b cosine of x minus 3c sine of x plus x times b sine of x minus c cosine of x. Right? Then plus y prime. Y prime is yp prime is here. So I'm going to add, let's see, I'm going to add a plus b cosine of x plus c sine of x, and plus x times negative b sine of x plus plus c cosine of x. Right? So it's a little bit tedious, but we have that. Then what we can do is try to cancel out, simplify as much as possible. All right, so here there's positive b sine of x, and there's a same thing with the negative version here. And let's see, negative c cosine of x times x, there's a positive version there, so you can cancel those. All right, so that's gone. All right, so that's that. So what you get is, if you clean it up, definitely you have you still have a constant term here. So this is a. So I'm going to just put a here. All right. Then we have let's see, cosine term. So here is a cosine here. There's another cosine here. right? So negative 3b plus positive b, so it's going to be negative 2b cosine of x. Then we'll see a sine term, so negative 3c and a positive c sine. So it's going to be negative 2c sine of x. And that's everyone, right? Then we have to make sure that this is actually equal to right hand side, which is 2 minus sine of x, right? So from there, we can just match terms. So cosine term, the constant term is a on the left and 2 on the right. So a has to be equal to 2. Right? Then if you look at the cosine term, so which is right here. Actually, there's no cosine on the right, which means that the b has to be 0. So b has to be 0 because there's no cosine term. Right? Then lastly, sine term is negative 2c sine. You have to get negative 1 sine. Right? So we have to make sure that the negative 2c is actually equal to negative 1. Right? Then we can just divide through by negative 2 to get the c equals 1/2. Right? So therefore, we know the particular solution y sub p. Right? A is 2, so it's 2x plus, right, x times b is 0, c is 1/2, so it's a 1/2 x sine of x. So it's going to be 1/2 x sine of x, right? And that's a particular solution, and we got the answer there, right? That's it. I hope that this was clear.